In lesson 7.4, we're beginning to look at the concept of a quadrilateral. As I told you yesterday, we're going to kind of start incrementing the number of sides here. So before we were just looking at angles, and then we started looking at three-sided figures, triangles, and now today we're going to look at four-sided figures, quadrilaterals. Then we're going to hit more than four sides in a future lesson, and then we'll kind of come back full circle here, no pun intended, and study circle shapes with no sides at all. So, quadrilateral simply defines a shape with four sides. It doesn't matter what that shape is, as long as it has four sides and it's a closed figure, it's a quadrilateral. Quadrilateral, the sum of the angles of a quadrilateral, always equal 360 degrees, no matter what that quadrilateral is or how oddly it's drawn. On the screen right now, you have the different relationships that exist among the different quadrilaterals. So here, we want to look at what those relationships are. So we'll start with the left and the right of the map here, because the left and the right sides of the map don't really show us a whole lot. They just give us some general information. Let's start with the right. On the right side of the map there, we have a kite. A kite has no sets of parallel sides. It has consecutive sides congruent, and that makes it kind of an odd shape. In some American textbooks, you won't even find a discussion of the kite. You used to, more often than not, only find kite in European textbooks. But as I said, kite is interesting because it has consecutive sides congruent. So if we look at the two left sides there, notice they both have one red hash mark through them. That indicates that they are congruent, or have the same measure. Meanwhile, if we look at the sides on the right there, they both have two red hash marks through them, which also indicates that they are congruent as well. And really, that's one of the few interesting features of a kite, is it has those congruent sides that happen to be adjacent to each other or next to each other. As we travel down the left side of the map, we have a trapezoid. Now, a trapezoid has only one set of parallel sides. If you look at the top and the bottom both have those red arrows through them. That indicates that they are the parallel sides. Parallel means if I drew them forever and ever and ever, in essence made a line of them, they would never ever cross, and you can see that. Contrast that to the left and the right side. If I drew those forever and ever on the trapezoid, clearly as we moved up, they would cross and make an upside down V shape, which would indicate that they are not parallel, because parallel means they would never ever cross. Trapezoid is really the only general name we have for a shape with one set of parallel sides. However, there is a more specific type of trapezoid known as an isosceles trapezoid. If that word sounds familiar, I'm glad. Isosceles implies, and when we talk about a triangle that has two congruent sides, an isosceles trapezoid would have the exact same feature, two congruent sides. And in this case, the figure drawn sure looks like an isosceles trapezoid, because the left and the right side there look like they have the exact same length. So that leaves the middle of the diagram, and as you can see, the middle of the diagram is certainly a little more robust there, when we're talking about parallelograms. Parallelograms have opposite sides that are parallel and congruent. So as we look at the top and the bottom, those have the same length and are parallel. And as we look at the left and the right, those opposite sides are also parallel and congruent. Now, we can get more specific when we talk about parallelograms, and that doesn't mean it has to be, it just means we can. So as we take that whole concept that I just gave you and add four right angles to it, that becomes a rectangle. Obviously, that's the only way that's different from a parallelogram, is it simply has the right angles. If we make all four sides the same, then we have a rhombus. So the opposite sides are still parallel and congruent. We have a rhombus. It just happens that all four sides are exactly the same as well. And when we take the idea of the right angles and the congruent sides and put them together, you can get a square out of that. Square has the opposite sides parallel and congruent, four right angles, and four congruent sides. So when we head down the middle of that image map there, you can be more than one thing. For instance, if we're a rectangle, that means you're also a parallelogram. If you're a square, that means you're also a rhombus, you're also a rectangle, and you're also a parallelogram. But again, that doesn't have to be the case. It could just be a parallelogram and be nothing else that's special. So you'll want to be looking for that as you answer here, because they will be asking you for the most specific name and probably then all of the names that apply to a certain shape. So as we look at 1A there, right away we see the right angles. So the right angles would be a tip-off that rectangle and square is possible there. And indeed we do see that all four sides are the same there, so that would indicate the presence of a square. But all those other names that we just talked about in the parallelogram part of the map, they're all going to fit here. Because we have the four right angles, that alone is enough to make it a rectangle as long as it's a parallelogram. It would also be a rhombus because it has the four congruent sides, and because it has the sides that are obviously opposite sides rather, that are parallel and congruent, that's how it becomes a parallelogram and then flows into all the other ones. So while the most specific name is square, this is also a parallelogram and a rectangle and a rhombus. As we look at B, we don't see any parallel sides here. Everything crosses, or if I drew them from, would cross. So that's kind of reduces the number of choices right away. We do see here that we have consecutive sides congruent. As we look at that shape there in purple, I guess we'll call them the left, or if you prefer the bottom two there, both have two hash marks through them, and the right or top two sides there both have one hash mark through them, so the consecutive sides are congruent. So that means that quadrilateral is a kite. And if you turn your head to the right about 20-30 degrees, it's probably a lot easier to see that being a kite than as it's presented on the screen.